Okay, for the next one, which is link G, you need to actually go to link G. This is a study jam video. So you're going to watch the actual study jam. Okay, it brings you right to the sedimentary rock. Okay, you can view the slideshow first. Okay, and it goes through the slideshow. It's hard to believe, but sedimentary rocks like this sandstone formation in Glen Canyon, Utah, are made from tiny bits of sediment. Pieces of rock, sand, and dirt are all sediment. The sediment is created through weathering and erosion. Wind, water, and ice all weather rocks. As the rocks weather, pieces of sediment are created. The sediment settles or deposits in one place and piles up, just like the Nockamixon Cliffs that run along the Delaware River in Pennsylvania. Layer upon layer of sediment settle until the weight of the sediment squeezes the sediment together. Minerals get mixed into the sediment and help cement the sediment together, like in close-up, we lost it here, like in close-up of the Bright Angel Shale Formation. So this is shale. All right, next. When shells and other matter fall between the layers of sediment, they become part of the rock. Sedimentary rock made up mostly of shell fragments is called coquina. The watchtowers of Castillo de San Marcos is made of coquina. Several types of sedimentary rocks are used for building. Limestone and sandstone are examples. The limestone fossil reef called Guadalupe Peak formed over 200 million years ago in present-day Texas. Because sedimentary rocks often contain fossils, they help us learn about Earth's past. Here you can see the shale fossil of an ichthyosaurus and 5 unborn babies. Okay, so it was a pregnant ichthyosaurus, I guess. The ichthyosaurus, oopsies, I lost it again. Let's try that again. The ichthyosaurus perished 66 million years ago before the dinosaurs. Okay, so then you're going to test yourself. So close this. And you're going to have to actually go to the test. Okay, now this test is in English. If you want to change it to your home language, what you need to do first is make sure you're in Google Chrome right here, Google Chrome. Right click, okay, on the screen, use the right hand button mouse and do translate to English. Okay, then click on options. And right here where it says translation language, you're going to change it from English to whatever language it is you want. So if you want Filipino, you would do that, hit translate, okay, and it will actually translate it to your language. Okay, or you can do show original and it goes back to English. But you need to actually go onto the site, take this whole quiz, and then on your paper, okay, you're going to write down your score, okay, right here, okay? If you got questions wrong, what were the topics you struggled with? So write down what the questions you got wrong were about. Okay, we finally made it to metamorphic rock. So we're going to go to this site here. Okay, I'm going to go back to my blog, site H, right click, click to allow it. Okay, this is an animation of metamorphic rocks forming. So this is an igneous rock called diorite, and this is telling you what the different minerals are. See how the grains are randomly oriented, meaning it's not in any order. They're all mixed up. Okay, if you look at the texture of this rock, there's no patterns or stripes or anything. It's just all mixed up. So this is some diorite. So now we're going to watch an animation of what happens under heat and pressure. So after extreme heat and pressure deep underground, rocks are exposed to high temperatures and pressure. Pressure squeezes the mineral grains. Aligned grains form foliation. So now we have lines instead of, see how it's all lined up? This was from this. So this is nice. Nice. Okay, so I'm going to click it again to watch the animation. Okay, so these are all random. Okay. We have zoomed in on the deep underground. We have high temperature and lots of pressure, smushing them down. The atoms all recombine to make new minerals. And it makes foliation because the grains are all aligned. They're in alignment. Okay? So you're going to draw a before and an after picture on your paper. Now that might be hard for me on this. I'm not sure. So before we had mineral grains. So here's my diorite. Alright. We have mineral grains that are, you know, all mixed up. Okay, after we have heat and pressure, we have some nice lines, okay? So this is foliated, this is non-foliated. Okay, so let's see. So heat and pressure oopsies, I tried to use my finger to write and that did not work out. So let's try this again. Heat and pressure cause diorite to metamorphose into gneiss. Alright, and that is site H. Okay, moving on to site I. Going to minimize. So we're trying to find out about how metamorphic rocks form and what some examples are. Now you might know some of these off the top of your head now, but I want you to still look at the site and see if you can learn anything new. Let's go to site I. Metamorphic rocks are made by either heating up or squashing the Earth's crust. They are often found in mountainous regions. One example is slate. Slate was originally a black mud laid down on the bottom of the sea or lake. Fossils can sometimes be found in it, but they are often squashed. Other common metamorphic rocks are called marble, gneiss, and schist. A metamorphic rock is a result of a transformation of a pre-existing rock. The original rock is subjected to very high heat and pressure, which cause obvious physical and/or chemical changes. Examples of these rock types include marble, slate, gneiss, and schist. They can be formed by pressures deep inside Earth by tectonic processes such as continental collisions, or when they are heated up by an intrusion of hot molten rock called magma from the Earth's interior. The coastline of Brazil is made of metamorphic rocks. These are shown here as stripy lines. Okay, so let's see what we need to know about. Metamorphic rock forms from pre-existing rock subjected to heat and pressure. So I'm going to say pre-existing rock. It's really hard to write on this. Okay, examples of metamorphic rock are, that's the wrong site. Examples of metamorphic rock, we have marble, gneiss, and schist. So on your paper, you can write marble, gneiss and schist. Okay, the coast of what country is made of metamorphic rock? And that country is Brazil. Okay. Okay, here's the next site, which is site K. I'm sorry, site J. Metamorphic rocks are the third type we'll look at. They formed from other rocks that are changed because of heat or pressure. Earth movements can cause rocks to be deeply buried or squeezed. As a result, the rocks are heated and put under great pressure. They do not melt. Remember, they do not melt, but the minerals they contain are changed chemically, forming metamorphic rocks. Sometimes metamorphic rocks are formed when rocks are close to some molten magma and so get heated up. Remember that metamorphic rocks are not made from melting rock, okay? Melting only forms igneous rock. So if you go to your paper, metamorphic rocks are not made from melting rock. Let's get rid of this pop-up. All right, so never. Okay, metamorphic rocks can contain fossils, but the fossils are, so let's see what it says. Metamorphic marble is another example of metamorphic rock. It is formed from limestone. Metamorphic rocks sometimes contain fossils if they were formed from a sedimentary rock, but the fossils are usually squashed out of shape. So they look totally different because they're smushed. Squashed. Okay, so metamorphic rocks are made from igneous or sedimentary rocks. Marble forms from limestone. And slate forms from shale. Oops. Okay, so if you look back at the page, it gives you that information right over here. So slate, which is formed from shale, okay, has layers. Marble is formed from limestone. And metamorphic rocks can be formed from any other kind of rock. So here are the two common types. Slate is formed from shale. Marble is formed from limestone. Okay, and I'm going to stop this video here because I'm running out of time on it. And the last video for Site K is next.